Hello everybody, hope you have got an idea on neural network and backpropagation from my last video. Today we will talk about some frequently asked questions on neural network. First, what are the practical applications of neural network? Character recognition from handwritten text. Of course, it is not easy to identify each character as a character can be written in various ways. Second example is object detection from an image. Then face recognition from a photo in social media. And how can I miss the famous example of self-driving car? Next is why neural network is so famous. Neural network has a remarkable capability of detecting patterns, identifying trends from a very complicated dataset. It can easily learn the non-linear and complex relationship between data. If we provide more data like millions of data, it will generalize the model more accurately. For traditional machine learning algorithms, that's not the case. After a certain amount of data, performance does not increase. Neural network has high fault tolerance. That is, if one or more cells get corrupted, it does not stop processing input to generate output. Next question may arise like, if neural network is so cool, why do we need other algorithms? Interesting question. As I already mentioned, there is no perfect machine learning algorithm which will perform well for any problem. If you do not have huge dataset, you cannot use neural network because it cannot train with small dataset and we will get very poor performance. As neural network is going to process lots of data for more number of iterations, it will require more powerful processor. Without powerful hardware, neural network is not an option. Very importantly, neural network model is kind of black box. If it accurately recognizes the pattern, we are well and good. But all the trouble starts when it does not perform as expected. It is hard to understand why it went wrong and how can it be corrected. It takes longer time to develop and train the model. So before applying neural network, we need to think if it is really worth to consume such powerful hardware resources as well as time. Next is why do we need activation function? I have already mentioned that neural network is based to find non-linear mapping. If we remember the diagram, neuron takes the weighted sum of its input and adds a bias and then sends it to activation function to decide whether this neuron should be considered as activated or not. So activation function basically adds non-linearity to the network, without which it would be a plain simple linear regression. Without this, neural net could not generalize pattern from complicated high-dimensional non-linear dataset. That sounds good. But how do we choose the function? First famous option is sigmoid. It has fixed output range between 0 to 1. If we see the curve towards either end, we will notice y value increases at a very slow rate. That is, gradient descent is very small or has vanished. What does that mean? It's actually network is learning at drastically slow rate or tending to stop learning. And other problem with this activation function is output through this function is positive, which makes it hard to optimize. Next option is tanh function. Its output values are bounded between -1 to +1. It solves the second problem of sigmoid, but vanishing gradient still exists. Finally, ReLU comes into the picture. It returns 0 for any negative input and for any positive value, it returns the value back. It's best used in hidden layer, but for output layers, we should use softmax function for classification problem and linear function for regression. Here, softmax function computes the probabilities for the classes in classification. Next question is, what is learning rate and momentum? By definition, learning rate is one of the most important hyperparameters that control how much we are adjusting the weights in network with respect to loss gradient. And momentum is a simple technique in neural network that often improves both training speed and accuracy. It accumulates the gradient of past iteration to determine the direction to go. Let me give you an example on learning rate. Suppose you showed 10 apples to a boy where all those were red. Now that boy thinks apples are red. Then you have shown a green apple to that boy and told that this is also an apple. With high learning rate, that boy will think red color is not the most important feature of apple. But with small learning rate, he may think this green apple is outlier and apples are mostly red. This notion keeps remain in low learning rate until he sees bunch of green apples. Let's see another example. Suppose you are playing golf and you hit the ball with extreme force. It will cross the hole. And on other hand, if you hit the ball too low, it will move a little. Hence, it will take too many hits to reach the hole. Means if learning rate is too high, it may fail to converge, and if it's too low, learning will be too slow. It's really tricky to determine the perfect learning rate. Instead of keeping a fixed learning rate during whole training process, it's better to start with comparatively large learning rate and gradually decrease the learning rate. Intuition is that at the beginning, random weights will be far from optimal value. So we can quickly update the weights using large learning rate, and towards the end, learning rate should be low to fine tune the weights. Before talking more on momentum, let's see why it is used. Why do we use gradient descent? That's a silly question. Obviously, it is used to minimize our cost function, or basically to reach the global minima in cost function graph. Ideally, cost function should look like this curve, and our objective is to gradually find out this point. So it's easier to find as there is no local minimum where optimization can get stuck. But in actual scenario, cost function is more complex and may look like this. We can easily stuck in a local minimum and may think we have reached a global minimum. And momentum is the superhero who helps us to avoid such situations. It tries to jump from local minimum by increasing the step size taken towards the minimum. If minimum value is large, means first convergence. But if both learning rate and momentum are large, it may skip the minimum with huge step. The equation for weight change will be like learning rate into total gradient with respect to weight plus momentum factor into weight increment in previous iteration. A crucial configuration of neural network is to determine the number of hidden layers and number of neurons in corresponding hidden layer. There is no hard and fast rule to determine how many hidden layer or neuron a good neural network should have. Simpler problems require comparatively less parameters, hence less hidden layer and less neurons in hidden layers, and for complex problem it will be opposite. It can be determined based on factors like number of input and output nodes, amount of training data available, complexity of function or mapping that it is trying to learn, and training algorithms. It's better to go by experimenting with one or two layers with few neurons, and through cross-validation we can compare the training accuracy and test accuracy. Based on accuracy, we can adjust the number of hidden layers and neurons. Keep few things in mind while selecting the number of neurons. Number of hidden nodes should be in between input and output node. It should not exceed twice of input nodes, and it could be 2/3 of input node plus output node. Next question is, what is the difference between neural network and deep learning? Deep learning is nothing but an artificial neural network with multiple hidden layers. It's basically a fancy term to multi-layer neural network. As deep learning is more complex than normal neural network, deep learning algorithm takes more data to train and requires more learning time, and of course provides better accuracy. I have tried to cover mostly asked questions on neural network at beginners level. If you have any other questions, please let me know through comments. Thank you.